Hi everyone, this is Professor Oaks and this video is about solving equations by factoring. So the first thing that we need to know to solve equations by factoring is the zero product property. So what this property says is that if you have, all right, so A times B equals 0, then either A has to be 0 or B has to be 0. So one of these has to be 0 because 0 times some number is 0 or a number times 0 is 0. Now, you can also extend that to more than two factors like A and B. So like A, B, C, A times B times C equals 0. If this is to be equal to 0, then what that means is that any of these three could be 0. So x minus 5 is 0, and x plus 6 is 0, and x minus 4 is 0. So if I solve each of these equations separately, then if I add the 5, x could be 5. If I subtract the 6, x could be negative 6. And if I add the 4, x could be 4. And so then I see that the solutions are, usually we write them in order from lowest to highest. So negative 6, and then 4, and then 5. So here are the solutions. Negative 6, 4, and 5. So those are the numbers that would make this equal to 0. All right. Here is a bit of a tricky question because it asked q plus 2 times q minus 4 times q plus 6 is equal to 0, then y. But of course, that should be q. All right. So same thing here. We have three factors, so any of the three could actually be 0 in order to make this equal to 0. So q plus 2 equals 0, q minus 4 equals 0, q plus 6 equals 0. We'll solve each of these separately. So q minus 4, minus 4 equals 0. I'll add the 4 to get q equal 4, but q plus 2 equals 0. I'll subtract the 2 to get q is equal to negative 2. And then q plus 6 equals 0. I'll subtract the 6 to get negative 6, so q is negative 6. And if I write these in order from lowest to highest, I have negative 6, then negative 2, and then 4. So the solutions are negative 6, negative 2, and 4. All right, let's try another example here. This one only has two factors. All right, so 5x plus 2 times 2x minus 5 equals 0. X could be what? So this is A times B. So we could set each of these equal to 0. Each of these factors equal to 0. So 5x plus 2 equals 0. And 2x minus 5 equals 0. So here, let's just solve each equation separately. So I'll start by subtracting the 2. So 5x is equal to negative 2. Then divide by 5 to get x is negative 2/5. Then 2x minus 5 is equal to 0. I'll add the 5 to get 2x is equal to 5, and then divide by 2 to get x is 5 over 2. So if I write these in order from lowest to highest, I have x is negative 2/5 or 5/2. What a time to be alive. All right, let's try another one. This one actually is a little bit harder because the expression is not factored here. So we have x squared minus 5x minus 6 is equal to 0. So I'll need to factor this. So a is 1, b is negative 5, c is negative 6. I've been using the AC method. So I'll break this up into x squared minus 6x plus x minus 6 equals 0. Then we have a GCF of x, so x times x minus 6 plus x minus 6 equals 0. Then factor out the GCF of x minus 6. Remember, that's 1 times x minus 6. I have x minus 6 times x plus 1 is equal to 0. Then set each factor equal to 0. So x minus 6 is 0. Add the 6 to get x is equal to 6. And then x plus 1 is equal to 0. Subtract the 1 to get x is equal to negative 1. But the question asks for the positive solution, so that would be 6. So try to remember your factoring if you did not actually already remember how to do that, all right? So let's try another one. X squared minus 11x plus 10 is equal to 0. So we need to factor this one. A is 1, B is negative 11, C is 10. So factor this x squared, all right, minus 10x minus x plus 10 equals 0. And then I'll factor out from these first two terms an x, so x times x minus 10. From these two terms a negative 1, so negative 1 times x minus 10 equals 0. Remember, I want these two sets of parentheses to be the same so that I can factor out the GCF, which is x minus 10. So I have x minus 10 times what's left, x minus 1. That will be equal to 0. Then set each factor equal to 0. So x minus 10 is equal to 0. X minus 1 is equal to 0. Then I add the 10 to get x is equal to 10. Add the 1 to get x is equal to 1. Then the question asks for the larger solution. And since 10 is bigger than 1, the answer is 10. All right, so I hope that you enjoyed that here. Now it's time for another wonderful example here. All right, so we have n squared plus 4n minus 32 is 0. So a is 1. So a is equal to 1. B is equal to 4. C is negative 32. So then I use the AC method again. So we have n squared. All right, so try to remember this for the rest of your life. All right, so that will be plus 8n minus 4n minus 32 is equal to 0. Then I factor out the greatest common factor. So I have n times n plus 8 minus 4 times n plus 8 equals 0. So I see that the GCF is n plus 8. So I have n plus 8 times n minus 4 is equal to 0. So then I set each factor equal to 0. So n plus 8 is equal to 0, n minus 4 is equal to 0. So if I subtract the 8, I get n is equal to negative 8. Or if I add the 4, I get n is equal to 4. Then I wanted the larger solution, and 4 is bigger than negative 8, so the answer is 4. I hope that you enjoyed this question here. So now let's try, you know what? Let's try this one here. All right, so here it is. Let's write it over here. So we have x times x minus 2 is equal to 15. This one is a little bit harder because all of the problems that we've had so far have had the equation equal to 0. This one does not have the equation already equal to 0. All right, so let's distribute the x. So x squared minus 2x is equal to 15. Then I'll subtract the 15 so that the equation is equal to 0. Then I'll factor this using the AC method. So x squared minus 5x plus 3x minus 15 equals 0. Then factor out the GCF. So x times x minus 5 is plus 3 times x minus 5 is equal to 0. The GCF is x minus 5. So I have x minus 5 times what's left over. X plus 3 is equal to 0. Then I set each factor equal to 0. So x minus 5 is equal to 0, or x plus 3 is equal to 0. Then I'll add the 5 to get x is equal to 5, or subtract the 3 to get x is equal to negative 3. But the question asks for the larger solution, so x is 5. Or did it ask for the larger one or the positive one? Oh, the positive one, but that's still the larger one in this case. All right, let's solve the equation below. So v times v minus 8 equals 20. So same thing here. V times v minus 8 is equal to 20. I need to get the right side of the equation equal to 0. So I'll distribute the v. So v squared minus 8v is 20. Then I'll subtract the 20 to set the equation equal to 0. And then I'll factor using the AC method here. So I have v squared minus 10v plus 2v minus 20 is 0. So I'll factor out the greatest common factor. So that would be a v and a 2. So v times v minus 10 plus 2 times v minus 10 is equal to 0. I'll factor out the greatest common factor of v minus 10. So I have v minus 10 times v plus 2 is equal to 0. Then set each factor equal to 0. So v minus 10 is equal to 0. V plus 2 is equal to 0. Then I'll add the 10 to get v is 10. Subtract the 2 to get v is negative 2. And the question asks for the positive solution, so the answer is 10. What a time to be alive, right? All right, let's try another great example here. And actually, do you need another one like this? I feel like at this point you don't actually need another one like this, but why not? All right, so m times 4 plus m equals 12. I'll distribute the m. So 4m plus m squared is equal to 12. Then I'll subtract the 12, but I'll also rewrite this so that it's m squared plus 4m first equals 12. Then subtract the 12. So m squared plus 4m minus 12 is equal to 0. And then I will go ahead and I will factor this. All right, so m squared, and this will be plus 6m minus 2m minus 12 is equal to 0. Then factor out the GCF, so that will be m times m plus 6 minus 2 times m plus 6 is equal to 0. Then the GCF is m plus 6, so I have m plus 6 times m minus 2 is equal to 0. Then set each factor equal to 0. And so then the solutions will be, when I subtract 6, negative 6, or add to 2. So the question asks for the positive solution, so m is equal to 2. All right, so now let's go on to a couple of harder ones. So this one we have 3x times x plus 1 is equal to, or minus, sorry, that's a minus, minus 15 is equal to 2x squared plus 4x plus 5. So let's start by distributing the 3x. So I have 3x squared plus 3x minus 15 is 2x squared plus 4x plus 5. Now I want to set the right-hand side of the equation equal to 0. So minus 2x squared. So I have x squared plus 3x minus 15 is 4x plus 5. Then minus 4x. So I have x squared minus x minus 15 is equal to 5. Then minus 5. So I have x squared minus x minus 20 is equal to 0. Then I factor, and I'll let you show these steps on your own this time, all right? So this will be x minus 5, x plus 4 is equal to 0. Then if I set each factor equal to 0, x minus 5 could be 0, or x plus 4 could be 0. So then if I add the 5, I get x is equal to 5. Or if I subtract the 4, I get x is equal to negative 4. And of course, this one was asking for the positive solution again. All right, let's try another one. Now, this one is a little bit more difficult, but let's multiply these out. So I know that z plus 1 times z minus 1 is going to be a z squared minus 1. So that's 5 times z squared minus 1. Or if you want to do it the long way, you can certainly do that. Z times z squared minus z plus z minus 1. And then z minus z is 0, so we have z squared minus 1. Then distribute the 26, so that's equal to 26z plus 26 plus 2. Combine the like terms and then distribute on this side. So I have 5z squared minus 5 is equal to 26z plus 28. And then I will go ahead and subtract the 28. So I have 5z squared minus, and this will be, what will this be? This will be, whoa, wow, 33 is equal to 26z. Then subtract the 26z, so minus 26z. Right, so I have 5z squared minus 26z minus 33 is equal to 0. And then remember how to use the AC method. So don't get confused on using the AC method. Just try to get this all correct here. And then if we try to do this, all right, so just try to remember how we would go about solving an equation like this one. All right. So, uh, oh, and by the way, this should be z anyway. So all I would say here is that a was 5, b was negative 26, c is negative 33, right? And so if you go through here and through all the combinations for a times c and b, you'll notice that this equation is not one that can be solved by factoring. So this cannot be solved by factoring. So I will tell you that in another class you'll figure out what this is. So this is not, that's not the answer. So this one cannot be solved by factoring, all right? But for today, let me just tell you that the answers are are approximately, all right, just so that you feel better about this, all right, negative 1.0551 and 6.2551, all right? But you'll learn more about that in a different class, but this is just today about equations that can be solved with factoring. So the conclusion here would be that this one cannot be solved by factoring. All right, let's try another one. 3x plus times x plus 1 plus 2 is equal to 2 times x plus 2. So let's distribute the 3x and the 2. So I'll have 3x squared plus 3x plus 2 is equal to 2x plus 4. Then let's subtract the 4. So we have 3x squared plus 3x minus 2 is equal to 2x. Then subtract the 2x. So we have 3x squared plus x minus 2 is equal to 0. And then I can go ahead and factor this one. So we have 3x and x equals 0. And then what will that be? A minus 1 and a plus that can't be right. Yeah, so that, no, sorry, that was me writing the wrong weird thing here. So give me a second to get the white out. All right, so let's see. So that should be a there we go. That's what I get for doing mental math, right? All right, so then this will be a 3x minus 2 and an x plus 1, right? So then each factor can be set equal to 0. So if I add the 2, I get 3x is equal to 2, and then divide by 3, so x is 2/3. And then if I subtract the 1, x is equal to negative 1. And then I look here, and the answer is actually not here, so none of these answers are right. All right, so this is 2 in a row where the answer was not even an option. All right, so now let's go to the next one here. Let's see, we have 5 times x squared minus 2x plus 2 equals x times 3x minus 1 plus 5. So let's distribute the 5. So we have that and then distribute the x. So let's have this as 5x squared minus 10x plus 10 is equal to 3x squared minus x plus 5. Let's subtract the 3x squared. So we'll have 2x squared minus 10x plus 10. And then let's add the x, so minus x plus 5. So let's add the x. So we have 2x squared minus 9x plus 10 is equal to 5. Then subtract the 5. So we have 2x squared minus 9x plus 5 is equal to 0. And then let's go ahead and try to factor this. So we have 2x and x. All right, so and just try to remember how this is going to work if we can factor this here. and I'll see that if you try to, and I'll actually wipe this out so that I can write this here right underneath it. But this is another one that if you let the A be 2 and the B be -9 and C be 5, that this one actually cannot be solved by factoring. All right, so that cannot be solved by factoring. So what does that mean? Well, that just means that this is a problem that we will do in a later class. And actually, the variable should be x here and not n. So I have no idea what's going on here. But I do know that I'll give you an approximate value of x again so that you can feel a little bit better about this. So 0.64922 is one of the x values, and 3.8508 is another one of the x values. So I hope that you enjoyed that problem here. So let's try another exciting example here. And this will be our last example. So here we have 2y squared times y minus 10 plus 90 is equal to y plus 30 times y plus 6 minus 90. So let's start by distributing the 2y squared. So we have, oh boy, this will be 2y to the third minus, oh boy, 20y squared plus 90. And then we'll go ahead and we'll distribute on the side to get y squared plus 6y plus 30y plus 180 minus 90. Then let's actually, and I'm crossing out this other problem down here because I'm not feeling confident that these answers are even correct on here, that the choices are even available for us. So now let's combine the like terms. So we have 2y to the third minus 20y squared plus 90. So that's equal to y squared plus 36y plus 90. Then I'll combine the like terms. So I'll subtract 90 from each side. So I have 2y to the third minus 20y squared is equal to y squared plus 36y. Then I will go ahead and subtract the 36y from each side. So I have 2y to the third minus 20y squared minus 36y is equal to y squared. Then subtract the y squared from each side. So I'm left with 2y to the third minus 21y squared minus 36y is equal to 0. Then I see that there's a GCF of y, so I'll factor out y. So y times 2y squared minus 21y minus 36 is equal to 0. And then I'll continue to factor here. So let me get another piece of paper. Actually, I'm not actually going to get another piece of paper. I'll just factor this for you right here. So y times 2y plus 3 times y minus 12 is equal to 0. So then I can set each of these equal to 0, each of the factors equal to 0. So the first one is y equals 0. And then we have 2y plus 3 is equal to 0. So if I subtract the 3, I get 2y is equal to negative 3. And then divide by 2 to get y is negative 3 over 2. And then I have y minus 12 is equal to 0. And then if I add the 12, I get y is equal to 12. And then the question asks for the positive solution, which is in this case 12. All right. So there we go. So that is the end of this section on solving equations by factoring. I hope that you enjoyed this video, that you're already looking forward to the next one. Thank you and have a great day.